Good evening, children. Now we are going to discuss a new lesson, sound. This lesson belongs to physics. Sound. We know very well this word, sound. How this sound has been produced. When an object is vibrating, and then it can produce a sound. In the objects itself, we have a molecule. That molecule is only making vibration. Then the propagation of sound takes place when the sound spreads into our surroundings. Here we have one activity. Take an empty tray or a matchbox, stretch a rubber band around it along the length, then plug the stretched rubber band. When the rubber band is stretched, what is happening? It is vibrating. Obviously, it hits the surface of the matchbox and then it is propagating. Propagation is nothing but it is producing a sound. And the next one, the metal pan. So even in our house itself, we are doing the same thing. When the metal fan, we can hit with the surface of any other wood or metal, it can make a sound because the molecule inside the metals can be vibrated. So when we strike it, it can make a molecule vibration, then it produces sound. Then the metal, two metal surfaces can hit together, then also it can produce a sound. Propagation of sound. Propagation means how the sound is producing. So when the friend was far away for you, then while calling him, you can make a sound. When you hear your voice, then only can turn back and then see you. Other than he cannot hear your voice means he cannot see you. The sound travels in a medium. For the empty space, we are surrounded with atmosphere. In the atmosphere, we have a air. Air is a medium to acting over there, and then it is taking a sound from one place to another place. Here, we are going to do an activity. Take a bell jar, that is a closed jar. Inside, we are going to keep one mobile phone. And then we need to close the jar. A vacuum pump. So in that vacuum pump, what we need to do, we can remove the air inside the jar. After that, what we can do, you can make a call to the mobile, but you cannot hear the sound because inside the jar, we are taken out the air. So it doesn't have any medium. So the sound produced by the mobile phone, we cannot hear. So in this experiment, we can know easily, sound needs a medium to move from one place to another. So in our atmosphere, we have a gases, so gas is acting as a medium. Thomas Alva Edison in the year of 1877, he invented a phonograph, a device that played the recorded sound. Now we all have a mobile phone. In that mobile phone itself, we have a recording option. But in the year 1877, so far it has 150 years ago, he discovered a phonograph, instrument to record a sound. Then again we have one activity, two stones they strike together and then they produce a sound. But when these two stones were under the water, strike it will not produce the sound because what will happen? The medium, their air is very less, the sound is also very less. So in the land and the water, the difference of sound we can have. Here we have a speed of sound. Speed of sound is denoted by the V. It is called velocity. V equal to n lambda. N is the number of frequency and lambda is a wavelength. Wavelength means how much the sound waves are traveling. Wavelength is the distance between the consecutive. Consecutive means next particles which are same space and vibrating to one place to another place. So the reverse form of Y, that we can call it as a lambda. It is the symbol for a wavelength. Frequency is the number of vibrations of particle in medium. In once again, it is denoted by N. The unit of frequency is Hertz. Based on this, we have a problem. A sound frequency of 50 Hertz and a wavelength of 10 meters. So V equal to N lambda, we already know. We are going to find out V. So 50 into 10, 500 meters per second. And then here they given sound frequency, they given speed, they given. We have to find out wavelength. So V equal to N lambda. In that itself, we have to find out lambda. Lambda equal to V by N. So 25 by 5. The 5 meter is the wavelength. Here are the some of the substances. They given how the sound was traveling. And then the sound needs a travel to medium from one place to another place. It depends upon the temperature, pressure, and then humidity. Humidity means how the air. It was a cold or hot. Based on that only the sound travels from one place to another place. The speed of the sound is 331 meter per second at a 0 degree Celsius temperature at 22 degrees Celsius. The speed of a sound particles temperatures and varies from different medium. Here they given solids, aluminium, steel and iron. So we have a different speed for the sound. Liquid, seawater and distilled water, very less. And then gaseous, it is hydrogen and oxygen 1284 and 360. The amount of water vapor, yes, the water vapor present in the air we can call it as humidity. And during the winter it's more humidity, but then during summer, in the summer no, it's a very dry place, so we cannot have any humidity in our around us. So sound travels in a different medium and depends upon the medium, it can produce a different sound. So for the understanding this, for the tuning fork. So tuning fork is a device to it's propagating a sound. So here it's a Y-shaped device. When it's a surface of the others, it will be vibrating and making a sound. So the vibrations are shown in the dotted lines. So it is vibrating and producing a sound. Sound waves. So sound is also in the form of a wave. How these sound waves are moving? It is also a form of energy. So when the periodic motion, periodic means for the particular time it is moving from one place to another place. So that energy has been transported from through the wave motion. And then we have two types of wave motions. That is transverse waves, longitudinal waves. Transverse means it's nothing but the vertical. Longitudinal waves means it's horizontal side. In the transverse waves, see how the wave are moving. It is a perpendicular of the direction. So when the flow direction, it is perpendicular to that. And the example waves in strings, light waves, etc. or transverse waves. String instrument we are using. So the waves in strings, the propagation of sound is like that in a string instrument. Longitudinal waves. It is also a type of waves. It moves in a vibration in a direction. It is parallel to the direction where the sound was propagated. Example waves in springs and then waves in a medium or longitudinal waves. It is the direction of the flow parallel to that. Next we have the seismic waves. The seismic waves are produced when the earthquake time and then the volcanic explosion. We cannot hear this earth, but in the seismology department they can know that the instrument used to measure these waves, seismometer. What are the properties of sound? Loudness. Loudness we know. When we can hear the long distance, what we can see, it's the loudest sound. And then when the drum is beaten softly, what is happening? We can hear for only particular limit, but it was beaten very strongly, we can hear for a long direction. This is called the loudness of sound. And then the pitch. The pitch is nothing but of the characteristics of a sound. The pitch between the male and female. Females have high pitch and then the male has a low pitch. But different pitch. Females only very louder voice, but males lesser than that. Quality of timbre. It's a characteristic sound. Same pitch and amplitude. For example, in the orchestra, we are playing a different instrument, but the sound we are hearing is same, but we cannot separate the different instrument sound. Audibility. Its audible range, we have three types: audible, infrasonic and ultrasonic. The human ear can hear the audible range of 20 to 20 kHz, and more than that or less than that the sound cannot be heard by us. And then the infrasonic, it's a more than 20 Hz, 20 kHz we cannot hear it, but some of the dogs, dolphin may hear it. What are the uses of ultrasonic? It is for use for the main monitoring system and the study of mechanism of human heart. Also these ultrasonic waves or infrasonic waves are important. Ultrasonic, it's a more than that Some of the birds and dogs can hear this. Human ear we cannot hear. It is used in the medicinal application as well as the sonar system to know the things under our sea. Another important application is the Galton's whistle. It is nothing but for the investigation purpose we are using dog. For that, dogs can hear the sound to know that. And then the bat can hear the sound of frequency higher than the 20 Hz, more than that. And then ultrasonic during screaming. These ultrasonic waves help them to locate the prey and then prey. Because bats cannot see properly, with the help of the echo only they can move from one place to another. Musical instrument. We have a different types of musical instrument. Wind instrument, a reed instrument, and stringed instrument, percussion. Wind. With the help of the wind, those instruments are working. Example, we have trumpet, flute, and then shennai and saxophone. A reed instrument is the help of the air. For example, harmonium and mouth organ, and with the help of the key notes we can make a sound. Stringed. Stringed means it was made by the metal string. Guitar, sitar, and then veena, violin, and all made by the stringed instrument. They can make a sound. Next, we have a percussion instrument. This is the instrument was made by the dry skin of an animal. When we touch the surface of the dry skin, it can make a sound. Drums, especially in the drums, we are having this sound produced by the human. So, how the sound was produced by us? In the diagram, we can easily know that structure of the larynx. So, larynx was in our throat side. It is located at the upper end of the windpipe we have in our throat. The larynx has two ligaments and then called a vocal cord stretched across it. So, if both the sides we have a muscle sound, when we stretch it, it can produce a sound with the help of the windpipe. Then what is happening? Through which air is blown in and out. So, air is going inside and coming out. And then the air pushed through the trachea for the larynx. When this air passes through the slit, the vocal cord begins to vibrate and produce a sound. When we touch the throat while speaking, we can feel the vibration. Because of these vibrations, make a changes in the pitch, and then we are producing a sound. Human ear. How the human ear was made for the audible purpose. So many animals can hear the sounds as we are able to hear the sound our ears. These ears pick the sound in the interpret high frequency vibrations. Ears of adequate animals designed to pick up high frequency vibrations in water. So human ear is called pinna. It is especially designed to gather the sound from the environment. So in our environment, the produced sound we can hear it, and then with the sound wave tracks in the drum we can easily hear. So here the structure of our ear, we have a outer area, and then inside we have a drum. How the percussion instrument, they have a skin. Likewise here also we have a skin. This skin, that eardrum, is reflecting the sounds what we are hearing. We have a middle ear, inner ear, and then outer ear. Middle ear is the main important because it only has a eardrum. Inner ear, it's a semicircular canals and then cochlea, and then these auditory canal has been present in the middle ear. And then when the noise pollution, every sound, it gives us stress because of what our ear cannot be bear that sound. That's why we can feel stress. So what are the results of the noise pollution? How to maintain it? For the irritation sound, we can close our eyes because it may make a nervousness and then headache. Long-term sound especially make our sleeping pattern change, as well as it affect our hearing ability also. Sometimes we can lose hearing, we cannot hear anything. Sudden exposure of louder noise, any causes heart attack and unconsciousness. Lack of concentration in work, and then loudspeakers can disturb the leading to the lack of concentration. Noise pollution affect the person's peace. Peace means it's disturbing our hours, and then the tensions result in the noise pollution. Controlling of noise pollution. So strict guidance should be followed, and then automobile vehicles, they can reduce the volume, and then people encourage the excessive handling of driving, industrial machines and home appliances. And then all communication system must be operated in low volumes. The residential area should be free from the heavy vehicles. Green corridor belt should be set up around the industries. People working in noisy factories should wear earplugs. People should be encouraged to plant trees and use absorbing materials like curtains and cushions in their home. That's all for today's class, children. Have a nice day. Thank you.